Good morning, guys. In this video lecture, we're gonna talk about the mates of gears, alright, on SolidWorks. But before doing this, I'm gonna state the equation of gears very quickly. In fact, guys, I know that gears are used to transmit the power, which means P1 should be equal to P2. And I know that the power is the torque times the angular velocity, which means T1 times omega 1 should be equal to T2 times omega 2. And I know that the torque is equal to the transmitted force from gear 1 to gear 2 times the radius of this gear. And remember, guys, whenever I say the radius of a gear, this means the radius of the pitch circle, not the addendum or the dedendum. So F transmitted times R1 times omega 1 is equal to F transmitted times R2 times omega 2. And this means F transmitted is equal to F transmitted, then R1 times omega 1 is equal to R2 times omega 2. And from here, guys, comes this relation R1 over R2 is equal to omega 2 over omega 1. Omega 2 over omega 1 is the velocity ratio. And that's why, guys, there is a small gear called the pinion that has the highest angular velocity from here. And the largest gear called gear has the lowest angular velocity. Not only this, guys, we know that if we have two meshing gears, we should have the same module in SI unit. In English unit, it is called same transversal pitch. All right. Now here, same module, and the module is equal to D over N. It's in millimeter. So I know that the module is equal to D over N. Now what is N? N is the number of teeth, while D is the diameter again of the pitch circle. And this means, guys, since M1 is equal to M2, then D over N for the first gear. So D1 over N1 is equal to D2 over N2. And then if you gather these two equations together, we know that D is equal to 2 times radius. Then R1 over R2 is equal to omega 2 over omega 1 is equal to N1, big N1 number of teeth, over N2. Now, this is a very important relation that we should know in order to do some meshing gears, because if we don't put the same module for gears, then there will not be any meshing between gears on SolidWorks. So let's do it now on SolidWorks. I'm gonna teach you the easiest way to do the meshing of gears. Let's start. So first of all, guys, what you have to do is to open assembly. All right. Now, why I'm opening assembly before doing parts for matching gears? Because in fact, I can bring these gears from my library. So I'm gonna say yes. And then, as you see, guys, the assembly is open, and then SolidWorks asked me if I want to find the parts that I want to make them, but I'm gonna click on X because in fact I don't want to use some drawn part. I'm gonna use them from the design library. But before bringing them from design library, guys, remember that the pitch circle should be tangent, and that's why I'm gonna sketch in the front plane, for example. You can of course use any plane. So normal tool, sketch inside it. I'm gonna sketch two circles. All right, guys. So I'm gonna click on circles here, and then I'm gonna draw the first circle. Draw the second circle, and then, guys, I'm gonna specify the dimension, and put on your mind, guys, that for gears the dimension is very important because they should have the same module, which means they should have the same diameter over the number of teeth. So the first smart dimension for this one, it should be, let's take it as 50, or yes, let's take it as 100 because this is the diameter. Second one, let's take it as 50, which means here the velocity ratio is 100 over 50 or 50 over 100, depending on where we should put the input shaft. So it's either 1 over 2 or 2. All right. So I'm gonna say yes, and then, guys, I'm gonna make them tangent So I'm gonna click on the first one, shift the second one, or first of all, let's remove the smart dimension. So let's click on the first one, shift the second one, and specify here, so and add relations that they should be tangent. And then guys, I'm gonna also click on the first point, the second, shift the second point, and then make them horizontal, all right, so that they are located on the same horizontal line. Now of course what you can do also is to draw a center line, and on the center line you can draw two circles. Now guys, I have two tangent circles. These will be my pitch circles. Now what I have to do is to go to here, design library, and then select toolbox, add in now, select any metric, but I'm gonna use this one as I metric, and then go to power transmission, because as we said, the gears are power transmission tools. And then here you can see the gears, and then you have to use spur gear. All right, now what's the difference between spur gear and helical gear and any other gear? Spur gear is the most simple one, where the teeth are parallel, and here guys, whenever you select the spur gear, you mean external spur gear, because as you can see here, there is some internal spur gear. What's the difference between external and internal? As we know guys, external gears will have different velocity, opposite velocity direction. All right, so I'm gonna select a spur gear. You have to drag it. Whenever you drag it here guys, and you remove your finger from the mouse, alright, then you're gonna have the first gear with its configurations. Alright, so what I'm gonna do now is to specify the module. So what will be my module? I know that this gear, let's say that has a diameter of 100. So if I specify the module here, I have to change the number of teeth. All right, so let's say this has a diameter of 100. Let's make the number of teeth, or let's take the module as 4. Then this means guys, since the modulo is equal to d over n, then the number of teeth should be 100 over 4, which is 25. Since yes, this is 25. All right, now you can keep the pressure angle because it's almost always 20. You can also change the face width of your gear, but here guys, I want you to focus on this one, on the nominal shaft diameter, because in fact make it in the range of the diameter. Since the diameter is 100, so make it, let's say, 20 so that you can see it, alright, because we're gonna use it in advanced made for gears. Alright, so then click OK. Alright, now you can put another spur gear here and then edit its configuration so that you don't have to go to the design library again and select another gear. So I'm gonna put another gear here, click on escape, and then go to the second one and adjust it. How to adjust it? It's from here, edit toolbox components. So guys, here you should keep the same module, otherwise you cannot have meshing gears. Remember, this gear has a diameter of 50, which means I have to divide 50 by 4, and this means that the teeth should be 12.5, which is not okay guys. I cannot have 12.5 teeth. Alright, so the number of teeth is always integers, and that's why I have to adjust the diameter of gear. Let's make the second one, if the first one is 100, let's make the second one 80, so that 80 over 4 will be 20. Alright, so I'm gonna put here the number of teeth as 20, so the module will be 80 over 20 is 4, yes, and then I'm gonna increase the nominal shaft. It shouldn't be, if the diameter is 40, then the nominal shaft is 10. If the diameter is 80, yes, it could be 20. Why not? So keep it to 20. Alright, so I'm gonna click on OK now, but don't forget I have to go back to the sketch and edit it. So the second one here should have a diameter of 80. Alright, guys? Okay. So now, guys, I should start my mate. So these are my two gears that I need to assemble.